So good afternoon. Very excited to see you all here. My name is Kevin Jacobson, and my colleague's David Higgins. I'm not going to give you our full resumes up here. I'm not applying for a job. But I am going to say that between the two of us, we have about 30 years of experience in the PPM and or simulation space. And we are very excited to be here sharing our message about strategic portfolio and resource capacity planning, specifically using simulation. And we have a third person helping us today, Scott Adams. I'm a big Dilbert fan. And that'll just be used to reinforce a few points and to give me a chance to get a drink every now and then. And by the way, I have complete confidence in my slides. So. Okay, I'm going to recap the agenda for the recording and for those who are just joining us. We're going to start by just giving a quick overview of simulation, and then specifically talk about how it helps with project selection and resource planning, resource capacity planning. Next, we're going to talk about how that works with Project Server, and specifically enhances existing projects that we already have in our server, and then allows us to do predictive analytics on those projects. And finally, we're going to be doing a hands-on experience looking at discrete event simulation, and I'll explain what that means, discrete event simulation. So to begin, why are we going to use simulation? I'm asked frequently, so what is it you do? And I say, well, I work with simulation. And people are like flight simulators? And I'm like, yeah, I just started saying, yeah, sure, only for business. Because I kind of gave up trying to explain it in detail. But it's very, very valuable by providing this low-risk approach to do an experiment before flying the real thing, for instance. I mean, how many people flew here? Would you feel comfortable if your pilot came right out of his classroom and then got right behind in the seat of the plane? Probably not at all. You know, we expect our pilots to go through some sort of simulation to diagnose potential issues with their instruction, with their flight, and then to experiment with different courses of action. So they can experiment with their approach and figure out, whoa, I came in way too hot, I need to slow that down. They can learn from that. But in the real world, how many times do we get into an executive meeting with our portfolios, we make some decisions, let's do these projects, let's do them at this time, let's prioritize them such and such, go. We just go out there and start executing on them. And then a month or two or three later, we start to find problems and then start to try to solve those in flight. Has that happened before? So simulation gives us a way to, at a very low risk, try out those portfolios before we start executing on them. Another reason to use simulation, it's really a natural next step in this portfolio management maturity model. And typically we'll start out here with this intuition and eminence. This is kind of the foundation. This is where people are starting their portfolio management. They're saying, well, I feel like we should be working on these. These mean a lot to me. Or it's very imminent, like I had a sales opportunity come up. Let's go chase these projects. Let's go chase these opportunities now. That evolved over time, and people starting to go into data-driven decisions using KPIs, our key performance indicators, or return on investment, saying, well, what are these projects going to yield? Now I'm going to make a better decision about which ones I select based on that. We evolved into project prioritization. Let's look at all of our different business drivers. Let's weigh them against each other. Let's weigh them against our projects and try to get a value for our portfolio and chase that value. And at the same time, let's look at some basic constraints around that portfolio. I want to do all these projects. I want to get all my value. But do I have enough people or money to do them? And that's kind of where a lot of organizations are today. That's where we kind of get to with Microsoft Project Server. Simulation helps us go to some next steps where we can look at our constraints and actually see how they impact our schedules. Do an evaluation on our constraints. If I don't have enough people, do I just not do enough of those projects to be under that capacity line? Or do I actually see how my projects are going to be delayed by not having enough people and or money? And then we can start to do these experiment on our decisions, doing our scenarios. Finally, if we want to go really mature, we can start doing some intelligent optimization, let a goal-seeking algorithm, weigh all of our different business drivers, our competing objectives, and start suggesting courses of action for us. And then we can look at additional constraints, such as quality, compliance, even weather, so on and so forth. And finally, we can check for robustness. So what is simulation modeling? Essentially, it's a computer model imitating the real world. It lets us experiment on our portfolio to determine remedies, find problems and determine the remedies. And it runs forward in time to give us tomorrow's result today. So let's look at a really quick example of that. Here we are looking at a model. Some engineer built this of a process. This is a process model. And I'll relate that to a project model in a moment. But someone has gone in there and they laid out all their different locations, and they put in the workers who are going to do their work, and parts are running through the system. And when we run this as a simulation, we can see that up in the top we have a clock, we're running in time, and we're going into the future. We're running this process in a model on the computer. So in the project world, where is your model? Fortunately, we don't need to have engineers laying out our model. Our model's already in Microsoft Project. So congratulations, you're all modelers. Now we just need to become simulation modelers. We need to bring this project plan to life and run it into the future. So how does simulation help with project selection specifically? So let's just go over a few key points here. We do realize that an organization's strategy is fulfilled, maybe not equal to its project selection, but it's fulfilled by the projects it selects. And when we are selecting our projects, we are going to use this analogy here. We have our tree analogy. Has anyone seen this analogy before? We're saying our strategic goals are the fruit. This is what we want to accomplish as an organization, typically measured in KPIs. You know, I want this kind of revenue. I want this kind of customer satisfaction. I want this kind of on-time deliveries. We have all this fruit we want to grow. In order to grow that fruit, we have projects that we work on. These are going to yield our strategic results by completing these projects. However, we do have constraints, and this is the root of our tree. These can be people, FTEs, resources. We might not have enough of them to do all the fruit we want. Money, quality, our supply chain could be a constraint. We have a whole other lot we could account for: weather, compliance regulations, complexity, et cetera, et cetera. Any shortfalls that we have here at the bottom in our roots, in our constraints, will yield less fruit and smaller fruit. And one other thing to keep in mind, these strategic goals, they're often in competition with each other. I'm a big fan of this one. There's so many things we want to do, but maybe that one's not as important as this one and that one. So that's why our pairwise analysis and Project Server, really good way to help us determine our priorities. But it is important to think of these priorities. And our constraints are also often in competition with our strategic goals. So here we've got pointy-haired boss. He's got a top-down, a strategic goal. I need you to get that thing done sooner for a trade show. But we do have, only so much, capacity to do that. In this case, it's complexity. So a little bit more about project selection and constraints. And we do know, we can agree that we want to identify the portfolio projects that yield the most value. We need to understand how to prioritize them based on this value. This is where our business driver analysis really helps. But it's important then, once you have those projects in mind, to align them to an organization's capacity. So on our little drawing here, we show we have capacity over time. And this could be any number of capacities, whether it be FTEs or money, so on and so forth. And we have projects that have demand against that capacity of varying amounts. And it's important to not only pick the projects to get us the value that will still be within our capacity, but also schedule them at the right point in time. And we'll talk about how simulation really helps with that. And this is really the crux of it. There's a lot of things we can say to try to achieve our goals, but when it comes down to it, it's really making sure we have the right people in the right place at the right time. Even though I do hear from my boss a lot that just get it done. All the time. Just get it done, KJ, just get it done. So one point to make here, we have these different boxes of projects. This can represent our demand. Now, these boxes are represented by different sizes depending on how much demand our project requires. But one thing that's interesting to point out is those are not always the size we think they are. You know, these boxes could, when we actually go to run our project, could actually be bigger or smaller than we thought. And this is a really important reason why simulation helps us. We estimated the size of that box. We said, that project needs this many resources in this point in time. It needs this much money over time. As well as, here's when I think I can get that project done. It's going to require this amount of time. However, there's a lot of risk there in having these estimates that are single-pointed estimates. For instance, I can say, oh, this pond, it's 10 feet deep, it's safe to jump into. But there is uncertainty there on specifically how deep that pond is at any point in its length there. So what are some of these dangers or some of these problems with these estimates, these averages that we've gotten? Well, they're rarely 100% accurate. If I say, hey, I have a phase that takes about 50 days, that's an estimate, but is it going to take 50 days? Does it always take 50 days? No, I mean, that can vary. It could be less, it could be more. However, those typically become commitments. Once I have a project plan and it's scheduled it out and I put in just single durations and I put in a certain amount of resources for that plan, it's going to tell me when my project's going to be done, right? Even though I could say, well, that's our estimate, but it might take longer. Those actually very commonly become commitments at that point in time. And additionally then, even if we know it may take longer, we still have to guess at these buffers. Oh, maybe I should add another week or two to that project plan. Maybe I should add X amount more dollars to my budget just to make sure. But how are we getting to those buffers? Are we saying, well, in order to be 90% confident I can get it done by a certain date, I need to add this much buffer? There's really a challenge there using these estimates. Now, when I was a kid, on Channel 2 at 9 a.m., The Price is Right was on. And I loved The Price is Right. I even stayed home sick one day, pretended to be sick one day, just so I could watch The Price is Right. And I never did that again because then it was followed up by like 4 or 5 hours of soap operas. And that was, as a kid, that was not ideal. But my favorite game on The Price is Right was the Plinko game. Who's seen the Plinko game on The Price is Right? I love that one. It's just fascinating, this idea that I don't know how long, I don't know where that ball is going to fall, but I do know a range. And very much like the Plinko game, realistic estimating deals with that uncertainty. We know once we start executing our project, it's going to have one outcome, but we don't know what that outcome is yet. We don't have a crystal ball. However, if we could do that project over and over again, we would start to see some likelihoods, or if we asked, or if we did an estimation a little bit differently, we could try to predict those. So if I drop my Plinko chip, I'm going to start seeing how it falls, and I'm going to start seeing a range. Now, we could assume for this example, I'm looking at maybe a key phase. And it's kind of wide, but I could say, well, optimistically, it could take as little as 10 days, maybe up to 35 days. Most of the time, it takes 20 days. And that is realistic estimating. And in a lot of ways, that's really quite a bit easier than getting estimates out of people. For instance, some of these other techniques, PERT. Who's familiar with PERT? I take worst case, best case, most likely. Why not just stop right there and use that? Instead, it puts it through an equation, and it still comes out with just a single number, which is not going to be the right number, and then leads to some of those problems we talked about earlier. Delphi or planning poker are very similar. I'm going to take either some experts, or I'm going to take my team, and I'm going to put them together, and I'm going to have them discuss the work and how long they think it's going to take. And they're going to have various opinions, and they're going to try to come to a consensus on one single amount of time or one single amount of work. Why not use the range they're coming up with as experts? And then my personal pet peeve is decomposition. And you're probably thinking, wait, well, Kevin, decomposition's more of an execution tool, not a strategic planning technique. But I see this all the time, where a project manager gets to the closeout of their project and things were late and over budget. And they're asked why. well, I didn't foresee these problems coming up. I didn't foresee this amount of work. I didn't foresee these kinds of unexpected costs. That's fine. We don't know everything in advance. But what that project manager tends to do the next time is tries to plan harder and starts planning more and more detail into their plan, simply in an attempt to capture this uncertainty that exists. But since we can't know all of the work that may happen in advance, that's typically less effective than just accounting for that uncertainty up front. And just, a comment on estimating. So how does this variability help with capacity planning? So let's take an example. I have a portfolio of projects. They're all going to require something out of a pool of either resources or money or other types of constraints. It's typically people, it's typically money. I can have a perfectly leveled, let's use that word, leveled portfolio, saying everything's scheduled out nice into the future. I know I don't have a whole lot of overlaps in my resources. I should have enough people to do everything I need. But once you include this realistic uncertainty, we start to see we have hidden constraints. In this example, I've got one project that's my high priority project, and then I've scheduled project 2 to kind of coincide with that. As soon as my engineer is done on that first task in project 1, then maybe that's kind of where I want to do project 2. I'm going to schedule project 2 accordingly. It's my lower priority one. But then what happens if I have some uncertainty here in project 1? That task perhaps takes longer. Well, that's naturally going to mean that then project 2 is going to be impacted. It expected the engineer to be available earlier, but now it's available later, sometime down the road, and now I've got a delay. Either a delay in the start of that task in project 2, or maybe I was able to get some engineering resources, but not all I needed. So I was able to start doing my engineering on project 2, but it's going to take longer. And suddenly this cascading effect of resource constraints and uncertainty is going to lead to some significant delays that I didn't foresee. Conversely, maybe on project 1 I got done sooner. Well, I lost an opportunity, perhaps, to schedule something during that engineering time because I've already decided project 2 is going to go now, and now I have this gap in time there where that engineer is available to do something, but maybe I'm not using them as effectively as possible. So where can I plug in this uncertainty? I used a few examples. Task durations is a big one. How long is it going to take to do these tasks, these phases? I can put a range on that. Another one's resource assignments. Maybe my tasks are set. I know it takes 20 days to do this phase, but how many people is it going to take to make sure it gets done within those 20 days? I could put some uncertainty around the effort. Cost is a big one. We may have a good idea of costs, but we might also have a range of costs, and we should be able to model that range. And likewise, revenues is a big one. If we have a product that's going to go to market, we can't expect it to perhaps ramp up and ramp down. As it hits market, it might not reach its full potential. It might hit some peak and then ramp down. But that total peak and how much we expect to make is almost surely variable unless we have a set contract ahead of time. And lastly, project survival. Is there any chance my project will fail or be canceled? If there is any chance that that's going to happen at any time, there could be key milestone stage gates, go, no-go decisions during my project. That I might want to model, because if that project is going to cancel in flight, that's going to free up a lot of resources to work on other projects. And I probably want to take that into account. And that is why it's so important to find resource capacity problems up front. You can't just all of a sudden throw 2 more people at something when it's when we've hit a problem. We need to plan ahead for that. Or it's going to be about as useful as his meeting there. Okay, when to use simulation? Project management, project execution, that's a day-to-day. Work management, task management, every day. Simulation's a little bit different. We don't need to use simulation every single day. That would probably get a little bit tedious, even though it's really easy to use. It works best when we're trying to do certain things. New project proposals is a big one. Let's see what projects we have right now in our portfolio, and then evaluate how additional projects, newly proposed projects are going to impact the ones that we're working on right now, how they're going to themselves be impacted by the existing ones, and try to understand our capacity versus those new ones. Anytime we're doing a portfolio prioritization scheduling exercise is a great time to use simulation to test and validate that our selection will really yield what we expect it to when we expect it to. Definitely, anytime we have changes in resource or budget availability, excellent time to use simulation. Anyone had their budgets cut? Ever? Yeah. But then are you expected to be able to do the same amount of work, or can you quantify what that decrease in budget or resources is going to do to your timelines? Can you go back and say, well, if I got 20% less people to do it, then these are the new dates you can expect? Simulation makes that kind of forecasting very, very easily. And finally, firefighting. Anytime I've got an emergency that I've got to solve, excellent time to use simulation. And that's a classic one. An emergency came up. Let's throw more people or money at that. Well, that's a good time to understand what that's going to do to everybody else. And finally, simulation is really helpful as a sandbox. Simulation should, when used with Project Server, be linked to it. We already have all this excellent data in Project Server. We've got our schedules. We most likely have plans with or without resources. But we do want it linked, at least coming in, so then we can play with this data in a sandbox. What can we do in the sandbox, then, simulation sandbox? We can do all sorts of what-if scenarios, and I'll talk about that in just a moment. And then we should be able to do project changes without feeling like we're going to impact our project managers. If we want to experiment with any changes to the project, simulation is a great place to do that. Maybe we want to try shortening or lengthening our projects and tasks. For instance, you might have a project manager who's always really aggressive with their schedules. I can get this done. I'll get it done real quick. Don't worry about it. And they're doing that maybe to get something approved. They want to work, or they have a pet project they want to work on. That should be easy to go, well, yeah, let's add 25% to all the tasks. Just make it a little bit longer. Let's just extend that project, just to realistically see how that's going to impact. I know that project manager is always aggressive, and it's going to take them longer. I know that. We should be able to just quickly add more time to it. Should be able to modify resource assignments without having workflow changes go out and having people notified that their tasks lists are different. Should be able to rapidly duplicate projects. Oh, I want to do projects like this one and this one, but let's do those next year and the year after that. I should be able to do that without cluttering up my execution system, without it impacting my other metrics. And finally, success and failure of projects, like I talked before. So this is a partner-led session, so we are going to actually demonstrate simulation using a specific tool, but in general, this is kind of how a sandbox with Project Server works. Project Server is on the left. We bring in our information into our sandbox, where we can then do all sorts of things in a project repository that's not going to be impacted by our what-ifs. We could add variability, like we talked about, add other risks, like our probability of success, our projects succeeding or not. We might be able to, we might need to add resources at this point, especially if we're doing an ideation. We have some high-level project plans that someone suggested or proposed. Maybe we've done a cost analysis, but we don't have resources on there, and we don't want to take the time to do a full, let's break it down into really detailed tasks and put resources on there. We might want to just use some rules to add resources. If it's this kind of a project with these kinds of custom fields or attributes, then we need these kinds of resources. It's a great place in the sandbox to add resources according to rules. We can add revenues or values, and like I said, we can modify those projects if we need to. Then, once we have all these projects in a repository, we can do what-ifs. We can start seeing any number of what-ifs. And I'm going to go into these in one more slide, and then I'll turn it over to David here. So let's talk about these. And then once we've done our what-ifs, that I'm going to talk about in just a moment, we are going to make some decisions about our portfolio. And once we start executing according to those new decisions, then we want that information back in Microsoft Project. So what are some really the common what-if scenarios? So just to recap, we're going to start with some project server data, create some scenarios, we're going to run simulations, and we're going to look at these outcomes and start making decisions. Most common one is probably, let's look at all my projects just as they are now, unlimited capacity, no changes, just what the project manager said, but look at my whole portfolio of them all at once, and use that as a baseline as I start doing what-ifs. The next one, this is very common, is to look at all my projects but with the current capacity I have on hand and do a resource impact analysis. This simply means that those projects are going to execute into the future with the resources I have available, and they are going to be delayed according to any resource shortfalls. My highest priority projects, they'll probably get the resources I need. Once I start running these, if I have really high priority projects, I'll say, I don't care what you're working on, you go work on that high priority one. But that's going to be at the expense of some lower priority projects. And those lower priority projects are going to actually start delaying and being elongated. And so we can compare what we expected with what might be realistic with resource constraints. Once we diagnose we have a problem, then we can start looking at solutions. Perhaps we drop some projects. We can delay the start of lower priority projects in order to try to bring our projects back on schedule. We can experiment with trying to get our projects back on schedule by hiring additional capacity or using more money. And this is an ROI. Is it worth the money to get these projects back on schedule by hiring these people? We can look at that as a scenario. We could reprioritize our projects. This is a very common one too. Our highest priority project got the resources and finished on time, but maybe it is all right for that project to finish a little bit later in order to get 2 or 3 more projects done sooner. I can rapidly do that kind of experimentation. Another one, we can look at our projects, but instead of hiring more people, we can just quickly get more people via outsourcing. This one is for project selection for ideation. Let's look at the projects we have now. And what if we add projects with or without adding additional capacity? Where might I have an opportunity to sneak in another project? 6 months into the future, a year into the future? Can I get another one in there? If I do squeeze one in, how is it going to impact my other projects? It's a very common scenario. And then we can start looking at our variability. Up to this point, we haven't even looked at variability, just capacity constraints around people and money. But this one might say, for the next 3 months, I think my estimates are pretty good. Let's just use them. I'm not going to try to get too fancy with variation. Let's use the next 3 months with the static plans I have now. But then going past that, I don't know my work as well as I do now. Short term, I always have a better idea of my work. Longer out in time, maybe that's when I should start using variability, this uncertainty. And finally, we could also do a scenario where we just use all the variability we need and any kind of probability of success or survival in those projects, whether they get canceled or not. And finally, we should have some reports that talk about that, but our reports really need to cover 2 things. One, they need to be able to look holistically at our portfolio from a scheduling perspective, from a financial perspective, and from a resource capacity perspective. But number 2, they should also show side by side my scenarios on any of the reports. Well, I have a scenario that was as planned. I had one that was resource constrained. What was the difference between those 2? I have one that showed I had more revenue than less revenue because of these decisions. So I can compare all my scenarios, one or more, side by side at a time, to understand those trade-offs. So let's do a hands-on experience here. I'm going to turn this over to David.
Yep, thank you. So KJ just went through what is simulation. And so the product I'm going to show you is our product. We're ProModel. And we have a solution called Enterprise Portfolio Simulator. Okay? And technically, it's a discrete event simulator, and that's what propeller heads would appreciate the name of it. But to me, and probably most of you as business people, what that really means is I can take my portfolio, I can run it forward in time, respecting project dependencies and priorities and resources, and get realistic outcomes. Okay? So let me show you our solution, and hopefully I'm not too loud when I talk. The first thing on the screen here is our repository, right? And how do we connect into Project Server? We come over here to import, and we drop down here, and we'd say, okay, bring them in from Project, or we can bring them in from Excel as well. And then I've clicked on that, and I want to show you how we can bring in these projects. We have a little import feature here. You could select those projects to import them. I could then say import the resource requirements here if you have resources in Project Server. But if you don't have resources or you want to create another set of resource demand, KJ mentioned we have what's called templates. I refer to them as rules. So we can create rule-based equations for resource demand. If it's this type of project and it's this type of complexity, I need this much of a product engineer. So you can create some very simple rules or some sophisticated rules to automatically generate resource demand. Okay. KJ also mentioned around variability. If you wanted to holistically apply some variability around your project estimates, your single point estimates, you can set those here. Okay. They would come in and then get a 3-point estimate instead of a single point estimate. And you can see both within EPS, either a single point or 3-point estimate. Okay? And as you look at data, you put ranges around data, you can look at the outcomes in ranges as well through probability percentiles. So we've got the projects in here. We have 10 projects. Looks very much like you'd see in Project Server. I can click on one of these. I'll show you, here's our tasks. Here's our duration. We then have resource requirements. You have conditions, so the task relationships. You have financial data. So here we have revenue. We have a revenue contour. So for those that want to bring in that element of data into your analysis, we can bring in revenue, and a revenue contour is nothing but some sort of curve that represents the life cycle of your revenue. And then we have attributes as well. These are user defined. They're fields that you'd set up. Important for a couple of reasons. Number one, it tells you more about your task or your project. Number two, it allows you to stack and slice and dice in your reporting, right? And then number three, as I mentioned those templates or rules, you can use these attributes for your rules. All right, so there's your repository. Now I'll tell you a little bit more here. Down here in the setup, this is where you put your headcount in. This is down at where you put your attributes. You can have any number of fixed costs. Now let's get to the scenarios, because this is where the fun happens, right? We've got two scenarios set up now. One is your plan dates. So I don't know if many of you if the projects at the executive leadership team just punch your way and say, okay, here's the project, here's the start and finish dates, get them done, right? So there's your plan dates. But now this next scenario is plan with resources. Over here we're saying it's constrained. The first scenario, imagine you have all the resources in the world. Next scenario, it says they're constrained. So what is, as KJ mentioned, the resource impact of that? So let's go over to the reports. And let's click on the typical Gantt chart. So there's your 10 projects, start finish dates. Let's do a side-by-side comparison. Now what we're going to see here, if your organization does not have enough resources to do the work, these projects are going to be pushed out to the right, the lower priority projects. So this immediately tells you, hey, we got headcount issues, right? We got headcount issues. So how do we further analyze that? Go to resources and utilization. Let's find out what skill type is giving us our challenges. So let's look at 2013. So what skill type is giving us our challenge? You can see here it's our product engineer. They're at 142%. So they're the reason why we're having delays. And remember, we're talking about simulation. We ran our portfolio forward in time, and based upon the priorities and the availability of resources, it's saying that we cannot deliver all your projects on time, and this is the bottleneck. It's 142%. So I can drill down further here and look at a time series, but I want to take you to our portfolio scheduler, because it will give us the same bit of information, but it will also allow you to analyze the data and check for alternatives. So here we've got all the skill types. We're just interested in a product engineer. They are a challenged one. So what I can do is there's the Gantt chart at the top half and then our supply demand in the bottom half. Let's see if we can level these resources. So I know that this project here is a low priority. Let me move it over to the right, and you can see the bottom half of the screen. We are dynamically adjusting these numbers. I can drop this one over here. That helps some. You know what? I may just drop out project 4. That's a low priority. Drop out project 6, right? And maybe drag this one over here. So you can see what's happening there. So if you need to address resource issues, you can go to the portfolio scheduler and slide and adjust the calendars to see the impact on the resources. Okay? So if we like this scenario, I can take it, I can copy it back. All right, snapshot 1. I can take it back to our EPS solution. It's been created. Refresh it, and now we have that new scenario, and I'm going to rename it. I'm going to say this is 3, and it's plan with changes. Okay, so let's say, you know, all you're examining is your projects and your resources, and you need to level your resources. We just went through the portfolio scheduler, and that may address your issues, right? That may solve your problems if it's only resource issues that you have. But what about if you have to include financials? You have a budget that you got to operate to. You've got revenue targets that you have to hit. So if we go look at the results of the scenario and we want to look at your cost and revenue, let's say that your budget is $900,000 and here you're exceeding it. Let's say your revenue target, let's look at it yearly. Your revenue target for 2018 is, let's say it's $15 million. But in the scenario where you had all the resources in the world, you can hit that number, 16.3. But what if we're doing plan with resources? Our revenue number looks different. It's a lot lower. Going back to the cost and looking at those two scenarios, you say, boy, there's some gap in there. There's gap in there where I think I should be able to spend some money to bring some other projects in so I can increase my revenue numbers. So how many folks in here have these competing objectives where you've got resource capacity, right? And you've got costs that you have to stay within, and you've got revenue numbers that you've got to hit. Is that real? Can I see a show of hands? Is that real? Do you have a good way of doing it now? No. Competing objectives, it's very difficult to do. So simply what I've just showed you is manual ways to test out different scenarios. I could do other adjustments to the scenarios. I could add resources if I wanted to experiment with that to see if I can get more projects done. Do I get the return on investment? I could, what else could I do? I could delay some more projects. There's a lot of different options, right? But for anyone to be able to figure all those competing objectives out is very difficult. So what's the answer? And I'll say we're here to say that there is an answer, and I'm going to show you that in our solution. So we've manually created scenarios. Now I want to introduce what we call our competing objective optimizer, right? So I'm going to take one of the existing scenarios, and I'm going to go to our optimization engine. Let me delete these guys. And here in our competing objective optimizer, you set your goal. What's your goal? Greatest present value revenue, greatest net present value. That's one that we often use. Highest resource utilization, highest project throughput. So let's select the greatest net present value. So that's our goal. What's our constraints? Let's say our portfolio cost is $900,000. That's our monthly cost. Now, in addition to setting a goal and setting the constraints, we also can grant permissions to our optimizer. We can force saying this project must start on this date, that project must start on that date, but these other projects, you can start them over a 3-year window or a 2-year window. You define the window. Okay? You can also tell it, well, these projects cannot be excluded, but these here, optimizer, you have my permission to exclude these if you cannot stay within my constraints and score high and hit my goal. Okay? So once you set those up, you can then go to the resources. These are your current headcount, but I can apply a range. I say, optimizer, you have my permission to hire up to 2 more product engineers. So that's how you set it up. There is no black box, right? It is not any sophisticated algorithm that you have to do. All you do is choose your goal, set your constraints, give it your project, give it your resource permissions. And this is all live. This is not makeup right here. And I'm going to hit go. And I'm just going to let it run for a minute. What it's going to do, it's going to run thousands of scenarios. Remember, we manually created a couple scenarios? Now, this is running thousands of scenarios for you. Right now, it's ran 512, 700 scenarios. And it's honoring your objective. It's honoring the parameters you gave it for project and resources and staying within your constraint. Okay, and let me drag this over and give it a little bit more real estate. So right now, it's chosen scenario 966 as the highest. Oh, now it just changed to 1998. And what it's saying is, of those 10 projects, it's recommending that you delay the start of those 3 projects. Oh, now it just changed again. So let me go ahead and stop it. It keeps finding better and better answers, and that's what it does. It's a learning optimizer. So let's stop it there. It's saying delay these 4 projects, and the return on investment is there to hire 7. It would be hiring 2 more product engineers. The other scenario here said just delay these 2 projects and only hire 6. But you can see it has a slightly less net present value score. So let's say I want to take this one and bring it over. All I have to do is select it and say, okay, that's a new scenario. You know it. So let's come back. All right. Let me go ahead and create. Oh boy, sorry about that. So it would come back and create a scenario that would include those changes. And let me go ahead and just duplicate this. Apologize. I may have. Let me restart this real quick. All tabs. Bear with me. PC14. All right. Come back to scenarios. Okay, let me go back to that. Rerun it real quick. Optimizer. Well, while I'm running this, why don't we just offer any questions so far? Do you have any questions?
So the question was, are we using the project server or project calculation engine? We are using our own scheduling engine in order for it to run forward in time and take into account these variability. So very similar to a Monte Carlo simulation, we have similarities, discrete event, Monte Carlo, like David said, it's like, just terms. But we do roll the dice, We do sample random numbers, so we have our own calculation engine for that. Then when you put it back into project, we will create these proposed new project plans. So if you did accept something that maybe had delays, then we will create a new project plan. So we're not stepping on the toes of the project manager. We can you can go through a governance process there to accept that back into project server. That's a good question. Other questions? Yes. Okay, so his question was, on import, are we assuming it's got generic resources, or do we have to have generic resources in project server? The answer to that is, there's so many features in there to just make it easier to do this. That's one of them, where you can take named resources, bring it in, roll it up to a skill set, or you can already have them in skill sets and bring them in as skill sets. We don't want to go through all the ways we've just tried to make this process easy, but that's one of them. Exactly. Exactly. So, we can either import them with named resources or pool them into their skill sets. Because typically you want to look at my current in-flight projects against future proposed projects, and those future proposed projects are almost always at the skill set level. No one's assigning specific named resources to those projects yet. But you still want to be able to compare apples to apples in your capacities. And so, yes, on import, that's an option.
And in this simulation, he said, $900,000 a month. But in the businesses that I'm going to be looking at in my company, we're capital constrained.
Yep.
So is focusing on a yearly capital budget one of the options that you can use in the optimizer?
Exactly. That is one of the options. It's important to be able to do a total capital cost, but also be able to look at costs over time. Because people typically have a budget in time chunks. And just to say, well, what's the total cost of my project? But my project's not finishing for 3 years, so I'm trying to unroll that cost over time. There's kind of a shortfall there that we try to fill by doing costs over time as an option. Let's see, other questions? Yes.
So are you actually simulating at the task level?
Yes.
Iteration?
Yes, so the question was, are we actually simulating at the task level? Yes, we are simulating at the task level. Those tasks might even compete for resources across projects at different priorities. My project may even have a high priority for some phases, but a low for others. And it's going to play against other ones. And it will level, yes, using those priorities. Yep.
Okay. So I restarted the tool and everything's fine. I went back in and reran the computing objective optimizer. The data is now here. So let me show you. Here is that scenario that we brought across, the plan optimized. I'm going to show you the changes that it recommended. It recommended project 1 would start on that date, project 5 to start on that date, project 6 to start there. potential project B to start there. Okay, so let's look at the outcomes. And we're going to look at net present value. So our maximum net present value is the first scenario, but we know it's unrealistic, right? The first scenario said, here's my start and finish dates. Imagine you have all the people in the world, all the budget in the world. This is what your NPV would be, right? It would be $77.4 million. Our next scenario is where we delayed some of our projects because we didn't have enough resources available. So it produced 74.4, but again, that's still unrealistic because it's only looking at, it's just delaying a few projects. And I'm going to uncheck this one. Now, here's the plan with changes. Plans with changes, if you remember, the purpose of that one is I had my product engineers was well over allocated, so we needed to delay projects. We even dropped a couple projects. So the NPV on that scenario is 65.8. Did it get us to where our resources need to be for product engineer? Yes, it did. But it really has a huge impact on our NPV. So what did we tell the optimizer to do? We said, optimizer, go out, find the highest NPV, stay within my limited resources, stay within my budget, and you've got my permissions to jostle the start dates of projects around. You have permissions to hire up to a couple more product engineers. And let's see what the score is for the NPV. You can see that it is much closer to what the maximum opportunity, a maximum NPV would be. But now this is a realistic outcome, whereas this first one was not realistic. Does that resonate with everybody? You see the value of it? Okay. So that's what I had to show you in our solution. Again, discrete event simulation allows you to roll your portfolio forward in time to get realistic outcomes. It's a sandbox to test all your delivery options, whether you have to, you're limited by your resources. Can I bring in more resources? Can I delay projects, drop projects? Can I outsource my work because I have more money than I have people? So it allows you to have that rapid what-if scenario to find what every executive is looking for from the PMO or the strategic planning group, a realistic, risk-adjusted, optimized portfolio, something that you can have confidence in moving forward and to deliver.
We are going to give you guys your time back. We tried to cut this, keep this within our time limit and even a little bit shorter. It wouldn't be useful for us to say simulation's valuable and easy to do if we, took 2 hours to explain it. I am going to go ahead and let you go and take questions up front so we don't have that uncomfortable, people are asking questions, I want to leave, I don't want to leave. But I will keep my microphone on as people are asking questions. So with that, thank you all for attending. I really appreciate your attention and your questions. They've all been great. Thank you.